Welcome to our C# Programming for Beginners course. Whether you're completely new to programming or looking to expand your skills, this course is designed to guide you through the fundamentals and beyond. The course is structured into several modules, each focusing on key aspects of C# programming. Module 1, Set up your environment and get familiar with Visual Studio. Module 2, Start programming with basic syntax and structure. Module 3, Explore data types and variables. Module 4, Working with strings and more. Module 5, Use flow controls with if statements, loops, and other control structures. Module 6, Using functions and methods to write reusable code. Module 7, Learn object-oriented programming with classes, objects, and more. Module 8, Handling and debugging errors. Module 9, File I/O. Along the way, you will also learn some finer tricks of the trade to make writing C# code easier. Make sure to code along with the tutorials. Practice is key. Try out different things and experiment with the code. It's a great way to learn. Regular practice will help reinforce what you learn. Let's get started and happy learning. In this module, we'll be looking at functions and methods. We'll start with an introduction into methods and look at what the parts are that make up a method. We'll explore how to return values from a method and how to pass values to a method through its parameters and arguments. We'll explain what polymorphism is and how it can benefit your programming. Then, we look at passing arguments as reference types and how it changes the behavior of the method. Finally, we use the bubble sort algorithm to demonstrate passing arrays into methods. We'll create a new project in our solution and set it as the startup project. If you prefer, you can continue on an existing project or create a new solution. Please refer back to Module 1 for the detailed steps on how to create a project. So far, we've used the program class's main method. But of course, an object can contain many methods. Methods are powerful tools. They are blocks of code that can be executed as many times as you want. It makes your code modular and maintainable in that you can put code you need to use more than once into a unit where it can easily be called again to execute, and you only need to maintain it at one place. After the main method, we write another method we called showMenu. All this method does is clear the console window, displays a list of menu options, and prompts the user for selection. Back in our main menu, we call this method. We do so by entering the method's name followed by parentheses. When your app runs, it will execute the showMenu method and the code it contains. Notice the reference indicator above the showMenu method. This shows us that this method is being called once from somewhere in your code. Of course, it's called from the main method. Let's look at line 11. This is called the signature of the method. It gives the method a name followed by parentheses. The parentheses can contain parameters to hold values or arguments you pass to the method when calling it. Before the method name is the keyword void. This simply says, this method doesn't return any value. Before the void is the keyword static. Because the main method is required to run your program, it is declared as static. This means it must be loaded for your program to run. This also means any method called in the main method must also be preloaded and defined as static. When we discuss objects in the next module, you'll see that C# will only load objects when they are required and need not be static or preloaded. Let's see the results of this code. Let's go make our showMenu method smarter. We want it to return the choice of the user. First, in line 11, we change the return type of the method to be a string. This will be the value returned when calling this method containing the choice the user made. We create a string variable to store the user's choice, then run through a do-while loop until the user enters a valid choice. It will continue looping while the user's input is not A, B, C, or X. Once the input is valid, the method uses the return keyword to say exit this method and return the value. Back in the main method, we call the show menu method and store whatever it returns into a string variable and display the result. Here, notice that we defined the variable choice twice in our code, once in the main method and then again in the show menu method. This is possible because of variable scope. Whenever you define a variable in a block, it will be only visible to that block of code. So the main method cannot see or access the variable choice in the show method. Let's run our app and see how the menu works. Let's write some methods that can accept arguments. First, minimize the show menu method by clicking on the arrow next to its name on the left. We'll create a method that can accept two int values and return the biggest of the two. Notice how we use the return command to quickly jump out of the method once it found the biggest value. Back in our main method, we create two int values. Then we call the biggest method, passing the values into the method and assign the result to another int variable. We run our code and confirm the result variable contains the biggest of the two int variables. Let's write a similar method, but this one can accept double values and returns a double. Note these two methods are the same, only their parameters are different. We'll call the second method from our main method using doubles. We don't have to pass variables into the method, but could instead just pass actual values into it. Our output shows the biggest of the two double values. Let's look at our two methods again. They have the same name, but one accepts int values and returns an int, while the other accepts double values and returns a double. C# allows two methods to have the same name as long as the rest of their signature is different. This is called polymorphism and is handy when, like in this case, you need to perform the same function but with different data types. When you call the method, the editor will give a pop-up saying there's two versions of this method. But the editor is also smart enough to know that you're expecting a double return value, and there's only one version of this method that returns a double. So the editor will choose to use the correct version. To demonstrate another feature of methods, we'll create a new method called swap. The swap method takes two string arguments, then simply assign the first argument to a temporary string variable, change its value to the second argument, and assign the first argument's original value to the second argument, effectively swapping the two arguments' values. In the main method, we define two strings, the first name and last name variables, then display their current values. We then call the swap method to change the first name to the last name and vice versa, then display their values again. However, when we run the code, we find nothing has changed. The first name and last name variables still have their original values. The thing with methods is that when you call them and pass variables into them, they don't receive the variable themselves, but only their values. So in this case, the method swap receives the values into new variables a and b, then swap them around, but the original variables are never changed. To fix this, we need to pass a reference to the actual variables into the method. We add the keyword ref to the parameters. Now it's expecting a reference to the actual variables, not just their values. When we call the method, we need to use the ref keyword again to pass the variables into the method. Running the code again, we now see that the values of variable first name and last name were successfully swapped. The last method example we'll look at demonstrates the bubble sort algorithm. The method will accept an array of integers and sort its values in ascending order. The first thing to notice is that the method is not using the keyword ref for its int_array parameter. That's because arrays are already reference types. The other data types we've worked with, the integers, the floating points, the string, char, and bool, were simple types that stored a single value. They were value types. Arrays, on the other hand, can store multiple values and can be of any size. So instead of creating a copy of its values in the method, C# passes the reference to the actual variable to the method. Arrays are reference types by default, and you don't need to use the ref keyword. But just like in the previous swap method, it means the actual values in the array will be changed. The method uses a very common sorting algorithm to sort the values in the array. It's called the bubble sort because as it loops through the array, it bubbles the higher values to the end of the array. Let's have a brief look at its structure. Line 59 gets the length of the array -1, then the outer loop runs through the entire array except the last element in the array. The inner loop runs up to the length of the array minus the outer loop's index. It then compares the current value with the next value and swaps them if the first is bigger than the next. This is how the higher values move up in the array. You could use a less than operator in the comparison if you wanted to sort the array in descending order. In the main method, we create an int array with some values in random order. We call the bubble sort method, passing the array to it. Again, notice we're not using the ref keyword. The method will change the order of the values in the nums array. Then we loop through the array and display its changed order. Thank you for watching this module of the C# Beginners tutorial. We hope it was informative and educational. Should any of the concepts not be fully clear, please go back to the relevant section and watch it again. To continue on the course, check out the links below in the description for the next module. Remember to click the like button and subscribe to our channel to stay up to date with the latest new content at Learn with James.